So next we are going to see the step-by-step procedure to plot the root locus in the exam point of view. Okay, so step 1 is find the open loop poles and zeros. Okay, so if I have given a question that g of s is equal to k by s into s plus 1, so this is the open loop transfer function and open loop poles and zeros. So here zeros are the roots of numerator and poles are the roots of denominator. So here the number of poles are 2, that is s is equal to 0 and s is equal to minus 1, and the open loop zeros is equal to 0. Okay, so first step, when you have given a question for plotting the root locus, first you should find the open loop poles and zeros. Then you should find the centroid, and the centroid is given by summation of poles minus summation of zeros divided by number of poles minus number of zeros. So for this question I have the poles as s is equal to 0 and s is equal to minus 1. So here the summation of poles, that is equal to 0 plus minus 1 minus summation of zeros. Summation of zeros is equal to 0 divided by number of poles are 2. I have 2 poles and number of zeros 0. So it will be minus 1 by 2. Okay, so here my centroid will be minus 1 by 2. Then step 3 is find the angle of asymptotes. Okay, so for finding the angle of asymptotes, we have the equation plus or minus 2q plus 1 into 180 divided by number of poles minus number of zeros, and q is varying from 0, 1, 2 to p minus z. Okay, so here we have p minus z is equal to 2 minus 0, which is equal to 2. Okay, so here we have 2 up to 2, that is q varies between 0, 1 and 2. So if we see these angles, we can see theta 1 is equal to 2 into 0 plus 1, that is 1 into the odd multiple of 180 by 2. Okay, 180 by 2, that is 1 into 90. Then theta 2 will be 3 into 90 and theta 3 will be 5 into 90. Okay, so it will be always the odd multiple. So if it is p minus z is 1, then p minus z will be 1, then it will be multiple of 180, that is 1 into 180. Okay, if it is 2, then it will be, if p minus z is 2, it will be the multiple of 90, that is 90 and 270. Okay, and if it is 3, it will be 60, 180 and 300, and if it is 4, it is 45, 135, 225 and 315. This is a table for, okay, so here p minus z is 2, hence we only have 2 values. Why 2 values? This 0 and 1. Okay, so q will vary up to p minus z minus 1. Okay, so this is a mistake, p minus z minus 1, that is if it is P minus Z is equal to 2, then 180 by 2. So it will be a multiple of 90 and there will be only two multiples, that is 1 into 90 and 3 into 90. If P minus Z is equal to 3, then I will have theta is 1 is equal to 180 by 3. 180 by 3 is 60. So theta 1 will be first multiple into 60. Theta 2 will be second odd multiple with 60, and there will be three values. Theta 3 will be 5 into 60. If P minus Z is equal to 4, theta 1 will be, there will be four values. First into 180 by 3 is 45. 45. Theta 2 will be 3 into 45. Theta 3 will be 5 into 45 and theta 4 will be 7 into 45. Okay, so those values are written here. Okay, either you can remember like this, that is if P minus Z is 1, then it will be 1 in only one value will be there, that is 1 into 180 by, this Q will vary up to P0 1 to up to P minus Z minus 1. Okay. Now step 4 is find the root locus on the real axis. Okay, find the root locus location on the real axis. Okay, so if I have the open loop poles like this and open loop 0 like this, then okay, this is my system. I have marked all my open loop poles and zeros. Okay, I have 2 poles and 1 0. Then how to find the root locus? Okay, so if we see that this poles and zeros divided the entire real axis into 1, 2, 3 and 4 parts. Okay, entire real axis into 4 parts. Okay, one is this part, one is this part, one is this part and one is this part. Okay, to find the location of the root locus, take a point in the first part. Okay, I have marked a point and look to the right side of the point. Okay, I have taken a point here and try to find the number of poles or the number of poles and zeros on the right half of the right side of the test point. Okay, this point is called the test point, and find the number of poles in the right half of the, if it is odd, then there will be a root locus, and if that is even, then there will not be a root locus. So here if I take a point here, then towards the right of that point there is no poles and zeros, so hence the root locus does not lie there. Now if I take a point here, then the number of poles or zeros to the right of this point is 1. So the root locus lie in this point. Okay, the root locus can lie here. If I take this 0, then there is even number of poles and zeros. So the root locus doesn't lie here. And if I take a point here, then there is odd number of poles and zeros, hence the root locus can lie here. Okay, so take a test point in each divided part of the real axis and look towards the right. If the total number of poles and zeros towards the right side of the test point is odd, then in that part the root locus can lie. So here we have taken this point towards the right, there is no zeros and poles. Then I have taken a point in this part. So here there is one pole. Okay, I have marked a pole here. So one pole, so that is odd number of poles. So root locus can lie in this region. And if I take this part, okay, here, then there is even number of poles, hence even number of total number of poles and zeros, hence root locus doesn't lie here. And if I take a test point in this part, then the total number of poles and zeros is odd, hence the root locus can lie from this 0 towards infinity. Okay. So when we do problem, it will be more clear. Find the next step is find the breakaway point and the break-in point. Okay. So it means that in a root locus starts from a pole, okay, starts from a pole and terminate at a 0. Okay, a root locus starts from a pole and it will terminate at 0 or at infinity. Okay, if p is greater than 0, then that is if p is equal to 3 and z is equal to 2, then two poles start from the pole and the root locus will start from the poles and terminate at the 0. Okay, and p minus z will terminate at infinity. Okay, so if there are 3 poles and 2 zeros, so the root locus will start from total number of branches of root locus will be 3, and out of the 3, 2 branches will start from the poles and terminate at the 0, and one branch start from pole and terminate at infinity. Okay, so it depends on the number of zeros to where the root locus will terminate. Okay, so if there are 3 poles and 2 zeros, then the total number of branches of root locus will be 3, and out of the 3, 2 branches will terminate at 0 and 1 branch will terminate at infinity. Okay, if p is equal to 4 and z is equal to 1, total number of branches will be 4. Out of the 4 branches, 1 branch will terminate at 0 and 3 branches will terminate at infinity. Okay, this is the meaning of now breakaway point is the point from which it will break from the poles and root locus will break from the real axis and meet at infinity, and the break-in point is the point at which it will meet at 0. Okay, break-in point is related to the 0 and breakaway point is related to the poles. Okay, this you can be more clear when you do more problems. Okay, now find the imaginary axis crossover point. For that we are using the Ruth array, and step 7 is the angle of departure and the angle of arrival, and this is specifically for imaginary roots. Okay, so up till now we are telling about the real axis roots. Suppose I have a root here and a root here. So about these two routes we have angle of departure and angle of arrival. Angle of arrival is basically for zeros and angle of departure is for poles. Okay. Similarly, breakaway point is related to poles and break-in point is related to zeros. Okay. So, angle of departure and angle of arrival, and angle of arrival is equal to 180 degree minus. So, sum of the angle vectors from the complex zero from all other zeros. Okay. Arrival is for zeros plus poles, and angle of departure is 180 degree minus sum of the angle of vectors to the complex zero from all poles to all zeros. Okay. First we have to find all of these from the all of these, and then we have to sketch the root locus. So, I have given an introduction only based on the exam point of view, but there are more in root locus. This is just basic steps in the exam point of view with all equations. Okay, let's solve some problems.